stuff open. So if I do a Python 3 scanner.py, and I'm going to come in here and just do a 4.1, and I hit enter, this could take some time. So what I'm going to do is I'm going to let this sit here. Actually, it's zooming through. You can see it found port 53 pretty quick. And then this might take time to find port 80 if port 80 is open. But basically what it's going to go through is go through port 50, 51, 52, 53, all the way through the process, and has that 1 second timeout as it goes through and checks each and every one of these ports. So it should take maybe up to a minute for this to work. So I'm going to go ahead and pause right here. Looks like we're almost done, actually. Port 80 came back as open too. No need to pause. It finished while I was yapping. So you can see it came back and said port 53 is open. Port 80 is open. So our script worked. It took forever to scan these ports, but it is working. So we were able to build out. Let's go back and look at this. This is awesome. We were able to build out a port scanner that came in here. And within 2 hours, you now have the knowledge to build out a basic port scanner. If you didn't think you would be able to do that, well, here you are. Look at you. You're awesome. Okay, so we were able to give it an argument. We set our if conditional statement. Make sure the length of the argument was 2. Valid. Otherwise, we have an else here. We made a little pretty banner. We imported some stuff. Got that all working. We did a try statement, which really was just a for loop in here. And we had some logic based on conditions that would happen within this for loop. We had a for loop and an if statement together. We used a f string to print this out. Pretty cool. Came through. We had some exceptions as well. For example, like the keyboard interrupt, just as to show you, if I come and run this again, if I wanted to stop this scan in the middle of it, I could just hit Control C and it'll say, hey, exiting program. And that's exactly what we told it to do. So you could say in here, it says exiting program. So that's the keyboard interrupt. Same thing, we had exceptions for not being able to connect, or we had the host name could not resolve. We would also have those sorts of things as well. So you could test out those errors, see if they work for you. But other than that, we built a scanner. So this is project number 1. We're going to go ahead and move on to learning a little bit more Python, and then we'll go ahead and get into some more project work. So I'll see you over in the next video. Now we're going to take a look at accepting user input in our program and then how we can manipulate data with that input. So let's go ahead and make a new file. I'm going to just say mousepad, and we'll call this input.py. And I'm going to bring this over. We'll give this the shebang, bin Python 3 here. Save it, get the pretty colors. And in order to take input in Python, all we actually need to do is just use input, something like this. So we could say like, enter your name for input like this, and put a space. And we'll need to put this into a variable. So if we come into the front of this and we just say name is equal to, we could do something like that. And then we can just print out like hello and give a space, do name, and then we'll add an exclamation at the end or a period at the end. Doesn't really matter. And then we can just come in here and save that. And if we run this, close this out. I forgot to add an ampersand, so we'll do that real quick. And if we run this now, we just say Python 3 and we say input.py. I'll say enter your name. I'll just say Heath. And you can see it says hello Heath. We can add upon this. We can say like, what's your favorite drink? So if we just make a variable and we call it drink, and we do input and say, what's your favorite drink? And do a question mark, something like that. We can come in here and then just add upon this if we want. We can just say, have a space plus drink plus period. All right, and it should say, welcome Heath, have a, and then whatever drink we put in here. So if we save this, come back and run it. Okay, I'm gonna put Heath as my name, and then White Russian is my favorite drink. And it says, hello Heath, have a White Russian. So we can easily accept input like this. So let's think about if we wanted to build out a calculator. I'm going to go ahead and delete this. What if we wanted to take input and make a mini calculator? We could definitely do that. So what if we had two numbers and we've been taking x and y? So if we said x is equal to input, and we'll just say, give me a number, and then we'll do something like that. And then we can also do y and also make that input, give me yet another number. You put whatever you want here, by the way. And if we do something like print x plus y, and we do that, let's save it, and let's see what happens here. So I'm gonna print this out. We'll give a number, we'll do 3, and then we'll do 2. And it gave us 32. Why is it doing that? Well, what it's doing is it is taking these and giving this to us as a string. So we need to either do an integer here and put this in an int, or we need to take this as a float. So if we think about this from the past, if we want to only take integers, we can, but if somebody were to put in like 8.7 or some number here, and they gave that to us, well, we would only take the 8 and we would leave off the 0.7. So I think if we're building out a calculator, it's better to use floats. So we can just come in here and say float, and we'll put this all in parentheses, and then we'll do the same thing right here. So now when we come in here and we save this and run this again, what should happen is this should work properly. So if we did like 3 and then 3.2, you'll see that we get 6.2, which is proper. That's awesome. Well, what if we wanted to build this out further? We could make this into a situational thing. What if we not only wanted to do an addition, but what if we wanted to allow the user to say, I want to add or subtract or divide or multiply or maybe use an exponent? We could do that. So what if we added another variable and we just called this O for operator, and we just took that input and we just said something along the lines of input, give me an operator, right? And maybe we put this in the middle here, so that way we're not just getting two numbers. Maybe we want to take that and we want to say something like this. So that way it'll say, give me a number, give me an operator, and then give me another number, and we'll print that out. So now let's think about how we want this to flow. If we want this to work with a addition like we already have, we might want to come in here and just say something like if O for our operator is equal to a plus sign, well then we'll come in and just print out x plus y. And remember, the indentation is important here. Else if, or elif, O is equal to a minus, guess what? We're going to print x minus y. And we can continue on here. Else if O is equal to division, we'll divide, and then we'll multiply as well, so x divided by y. Else if O is equal to multiply here, we'll go ahead and multiply that. Let's throw in an exponent for good measure. So let's do elif O is equal to an exponent. That's 2 asterisks there. And then we'll just print out x times y. So we've got a mini little calculator here. And we need to end this with an else statement. So what if we take input that doesn't belong here? If it doesn't match one of these operators, then we can just print something like unknown operator. All right, and just put a period there, save that, and this should work. So let's go ahead and give this a try. What if we come in here and we just say, give me a number, we'll do 3, and let's say we want to multiply, and we'll do by 3. And we get a 9. We can do it again. We can try something like, we'll do 4, and this time we'll do an exponent, and we'll do 4. So 4 to the 4th power is 256. So we have just quite easily built out a little calculator that we take input from a user and then utilize that to calculate that expression given what is given to us by the user. Now, let's think of something else here, just as an aside. What if something is written differently? Like when I think of math, with Python, yes, we think of 2 asterisks as an exponent, but what if we had a situation where we wanted to maybe use the up arrow or the caret symbol, which is how I've commonly seen it used online for math and exponents? Well, we could do something like or O is equal to the up arrow like that. And what if we save that and ran this now? And if we gave a 4 to the up arrow of 4, guess what? We still get 256. So we can use our statement like that here, our and, or other operators that we have learned along the way. So start thinking about it like that. As we start to piece these things together, we're starting to build out little projects, and we can use some of the logic that we have already learned throughout this course. So that's it for this lesson. We're going to go ahead and move on to the next one. Okay, now we're going to talk about reading and writing files using Python. So let's go ahead and make a new file. I'm just going to mouse pad, and we're going to call this file months.txt. And in here, let's go ahead and just type out the months. So we'll do January, February, March, April. If I could type May, June, July, August, September, October, November, and December. If you need to take a break and catch up, go ahead and do that. Save this, and once you have it saved, go ahead and close the file out. So let's go ahead and create a new Python file. So we'll call this mousepad, and I think we'll just call this readwrite.py. We'll do the ampersand here. And for this, what we're going to do is we're going to go ahead and look at how we can read and write files. So the way that we do that is with the open command. So we'll say something like open. And with open, and actually let's add the shebang up here really quick. In Python 3, save it. And with the open command, we can say something like open months.txt. And I need to add this here. So if we open months.txt, what we need to do with this, or what we typically do with this, is we store this within a variable. So we might just call this months equals open months.txt. And if we want to read that file, we can come in here and just print out months. And you'll see what this does here in a second. Now, best practice says to also close this out anytime we open this. So I'm going to go ahead and just add some lines in here because we're going to add some more stuff to this. But we can just do months.close. And we'll save this. Let's go ahead and run and see what happens here. So if we do Python 3 readwrite.py, you'll see we get this information back. Let me move this so it's readable. And what this tells us is, hey, this is the name of the file. We're in a certain mode, and this mode currently is read mode. And we get the default encoding here of UTF-8. So we're getting information back. We're not actually reading the file that we wrote. So some of the information that we can get, by the way, we can come in here and we can say to ourselves, well, is this file readable? So we have mode equals R, and this is one way to check it. There's a couple ways that we can check it as well. We can print out months.mode, and that will tell us what mode we're in. We can also print out months.readable, and that should give us a Boolean statement whether that is true or false. So if we come in here and we save this, and we do this again, you'll see that we get months. We print that out. We get the whole shebang here, and we get the mode is equal to R, which is readable. You can see if we print out the mode, we can also see it's readable. Or if we do months readable, we can see that it is readable. So we have the ability here to actually print this out and read this file. So how do we do that? Well, let's go ahead and delete these 2 lines. And we can just come in here and do month.read. If we do that, what happens here? Let's save it, print this out. And you can see that it reads through every single iteration, January all the way through December. Perfect. So we just read a file and we closed out, working as intended. If we wanted to read this line by line, we could. We can do months.readLine like this. And if we save that and print, we will read literally 1 line. If we wanted to read a second line, we could copy this and we could paste this and save it and come in here, and guess what? We'll get January and February this time. So if we want to read this, we have to read line by line. Now, if we wanted to read all the lines at once, we could do that in a different way. We could do that with read lines. And this will print out an empty array or a list here, actually. And what you'll see is we get January, new line, February, new line, March, etc. So we put this into a list. And now, if we try to actually run this again, let's actually tab over. If we tried to run this twice, look what happens. I'm going to print this and save this. So we have the first list here, and then we have a second list here. The second list is empty. Well, that's because we've actually already read this. So we read through it here first, and then it's empty the next time we try to read it. So if we wanted to read it again, what we need to do is actually use what is called the seek method. We can come in here and say months.seek, do 0 like that to go back to the very first line, and print out again. And now you can see we actually printed this out twice. So that works out well. We also have the ability to put this into a for loop to read through every iteration of the line. So if we wanted to do something like for month in months, we could just print out month. All right, and that should iterate through everything in here. So save that, print this. And you can see that it indeed does print through everything. We can also add the .strip at the end of this. Save that, print. And you can see that we strip out any of the new lines that are in there. So you saw we got some spacing in here, a little funky. So if we came through and we just added the .strip, that makes our for loop a little bit better. So again, remember, what we're defining here is whatever we want. We can call this for X in months, make this an X, and it's the same thing. But logically, it's just easy to call this month in months, and then we can just print those out. So we can iterate through this. So far, up until this point, all we've done is been able to read a file. What if we want to write to a file or append to a file? Well, we can do that as well. So if we wanted to, for instance, open a file, let's open a new file. Let's do something we haven't created yet. Let's do days of the week. So let's do open days. And if we try to do this, let's change months to days. And we're going to change days to close, and we're just going to leave this open right here so we have our best practice. Now, if we tried to run this with an open days.txt, we're not going to be able to do that because currently we're just in read mode. So we want to be able to turn over and put ourselves into write mode. In order to do that, we can just do a W. If we wanted to check that out, we could just do print days.mode like we saw before. Make sure we are actually operating in write mode. So if we save this, you'll see that we are in write mode. So we're good to go. You could also just, again, delete this, save, and print out days. Apologies. You print out days, save that. You'll be able to see that we are also in write mode. So both of these work. Now let's write to a file. So we've got days. Let's go ahead and write to that. So we can do something like days.write. And let's say we wanted to put Monday into days. Save that, close it. And if we go ahead and execute that, nothing happens. But if we go ahead and cat out days.txt you'll see that Monday has been put into days.txt. Perfect. So now, what if we wanted to continue on with this? Let's put Tuesday in there. And we're going to need a new line. So let's go ahead and do a new line with that. And we'll do Tuesday. And hopefully when we write this out, we'll see Monday and Tuesday. So let's save that. Print this. Sorry, let's run the script and then print this. And you'll see we have the new line in there and we have Tuesday, but we actually overwrote it. We don't have Monday anymore. So what's happening here is we're actually writing to a file, which is overwriting the file. We're not appending to the file. So if we wanted to append to the file, what we need to do is change this W to an A. And we can come in here and we can write in Wednesday if we wanted to. Save this. And now run this and run that. And now you can see we have Tuesday and Wednesday. So understand the difference between R being read, W being write, which overwrites, and A being append, which allows us to append a file instead of overwriting a file. So that is it for this lesson. I'll go ahead and see you over in the next one. All right, let's talk about classes and objects. So Python is what is known as an object-oriented programming language. So pretty much everything in Python is an object. And we can use what is called a class to be what is like an object constructor. And we can use that to help create objects. And this is a little bit easier to explain once we actually demonstrate this. So we're going to create a couple of files in this lesson. And the first thing that we're going to do is we're going to do a mouse pad, and I am going to create a file called employees.py. And in this, we're going to go ahead and declare a class. I'm going to save this here. So let's do class of employees, save it. And we're going to go ahead and hit enter and just tab over. And we're going to do this define and 2 underscores, init or init, 2 underscores again. And we're going to put some parameters inside of this function. And we'll talk about what the init function is here in a second. Let's go ahead and let's think about having employees. So the first parameter we're going to define is called self. And then for our employees, we might want to know the employee's name. We might want to know what department they work in. We might want to know their role in that department, their salary, and maybe the years that they've been employed. So we'll do years underscore employed. And just like a function, we'll add the colon here at the end. And we're going to go ahead and tab. And then we're going to define all of this. So let's go ahead and say self.name is equal to name. So we're creating methods here, which you'll see us use in just a bit. We're going to do self.department equals department. And you should get the gist at this point. Self.role is equal to role. Self.salary is equal to salary. Self.years employed is equal to years employed. Okay, so let's save that. So all classes have a function called the init function, and this is always executed when the class is being initiated. So we're going to use this init function to assign values to object properties. So what we're doing here is we're creating these parameters within this function, and we're also building out methods that we can use once we import this class. So let's go ahead and close this out, and we're going to open up another mouse pad, and we'll just call this something like our employees.py. You can call it whatever you want. And I'm going to go ahead and do my shebang at the top. We'll do bin python 3, save that. And from here, I want to actually import the class that we just built. So what I'm going to do is I'm going to import this, and we're going to say from employees, import employees. All right. And we can make a couple of employees here. So let's set a variable of E1 for employee 1, and we'll just do employees. And I'm going to stick with the Bob's Burgers theme from earlier. We'll just say we've got Bob. Remember, we're declaring Bob's name. His department, we'll say he works in sales. We'll say that his role within that department is the director of sales. And we'll say his salary is $100,000 a year, and that he has been employed for 20 years. And we'll do another employee, and we'll say that this employee is Linda. She is an executive. She is the Chief Information Officer, or the CIO. She makes $150,000 a year, and she has been with the organization for 10 years. So we can do some stuff with this. We can go and say like print e1.name. Let's save this, make sure everything works. Come in here. Actually, let me close and reopen this because I forgot my ampersand on this. And we'll come back, and now we'll go ahead and do Python 3 r employees. And you'll see that print e1.name is pulling down Bob. So we're using the name method that we created with our class. So we define that within that class. So now we have the ability to pull down information based on the class that we built. So we can also do something like print e2.role, and we should get that role printed out for us. So if we see e2 role, we're getting that she is a CIO. So that is accurate statement here. Let's see if we can open both of these. Let's open also employees.py, and we have both of these here now. So it's a little bit easier to see. We've got our function, our init function here, and we have all of our methods that we've defined. Now we can build upon this within this class. So let's say if we wanted to make another function, if we wanted to say something like define eligible for retirement, and we just said self in here as the parameter. What if we said something like if self.years employed is greater than or equal to 20, then we return true, because if the person has worked with us for 20 years, then they are eligible for retirement. Otherwise, if they haven't, then they haven't earned their retirement yet. So we can look at an employee and see how long they've worked with us, and we can save this here. And then we can come in here, we can do something like print, and we'll say E1, and we'll ask if they are eligible for retirement. Okay. Save this, print this out, and you'll see that Bob is indeed eligible for retirement because he has been with the company at least 20 years, which is what we put here within the class. So just know what we're doing is we're building out our own class, and we're able to define these functions and these parameters, and these help us with creating our objects that we're using over here. So we've got our classes, and then we've got our objects. So this can get really robust very quick, and we'll build out a project to look at that here in the next lesson, and that way we can tie this all together. But this is a very important part of programming, and this is very much a 101 class, so we're just skimming the surface on what this is. But this is actually incredibly useful when we start building out classes like this to help with other things that we're writing and pulling information from. So that's it for this lesson. We're going to go ahead and move on to the next one. We have reached the final project in this course, and this is going to tie everything together that we have learned thus far. So I am a bit of a sneakerhead, which means I really like shoes. And so what we're going to do is we're going to build a budget app using classes and objects, and we're going to see what shoes we can afford based on how much money we have. So we're going to go ahead and start with the class, and we're going to just make a new file. We'll do mousepad, and we'll call this shoes. I can type shoes.py, open that up, and we'll also open up a new window as well, or just a new tab here. and we'll write in both of these. So for this one, we're going to go ahead and just define a class of shoes. And I'm going to go ahead and just save that so I see the colors. And here we're going to define our init statement. And we're going to just say self. And then we're going to have a name, our name of our shoe, and the price of our shoes. And within this, we're just going to define self.name equals name. This should all look familiar so far. And self.price is equal to price. What we're going to do with the price, because we'll run into an instance where this is going to be taken potentially as a string, we're going to go ahead and just give this a float. We want to make sure that we are assuming this is going to be a float of a price here. Let's go ahead and define a few more things. So I want to define a budget check. And I want to make sure that we have the budget here. So what we're going to do in this instance is we're just going to say self, and then we'll also add in budget here. And we'll come in here and we'll do a check first. We want to make sure that we are given an integer or a float here when we are asked for the budget. So we can say something like if not is instance. And what this means is we're saying if this type is not what we're specifying here, then we're going to go ahead and reject this and close out of the application. So the is instance looks for a type and returns a true value. But if we say is not true, then that's false. Remember our truth tables, and thus becomes invalid and closes the app. So what's going to happen is we're going to say budget, and we're also going to look whether budget is going to be an int or a float. And if it is not one of those two things, we're going to go ahead and print out invalid entry. Please enter a number, something along those lines. And then we'll exit the application. So let's say that we have a budget and we want to also know how much money is left over if we buy the shoes. So we can define something like change, or what change is left over. And we can say something like self budget on this as well. And we can just return our budget minus our self.price. So remember, we declared self.price up here. Now we're calling it and we're just saying, hey, I want to return the value of the budget that we have minus the cost of the item that we're purchasing. Okay, only a couple more things and we'll be done with our class here. So we also need to purchase it, right? So let's define buy, and we're going to do self budget again. And here we're going to do a self.budget check. And we'll check our budget. And what we'll say is if our budget is greater than or equal to self.price, then we're going to print out. We'll do an F string here, and we'll just say you can cop some, and then we'll do self.name. So the name that we'll provide here. This will all make sense once we tie it all together. Okay, and then if our budget is equal to the self.price, then we're going to just say print out you have exactly enough money for these shoes. Otherwise, we can do else. Now we could go through this whole thing and give a statement and say, well, what if we had no money, or what if we didn't have enough money? But in this instance, we're just going to print out the situation of you can buy these shoes and have, we'll give a $sign here. We'll say self.change, and we'll give a budget left over. So we'll say left over, just like this. All right, and then when we exit the application, we can say something like exit, And we'll just give a statement. Thanks for using our shoe budget app. Now, this might not make any sense yet, and that's okay. Let me make this a little bit bigger. And so what we're doing here is we're defining our init. And in our init, we have a name, which is going to be the name of the shoe, and a price, which is going to be the price of the shoe. So self.name is equal to name. Self.price is going to be a float because we're expecting potentially it could be our price of our shoe could be $2.99 or $100.99. It might not just be a perfect number. So we want to use a float. We have our budget check here. We're just checking the is instance. We could, in theory, add to this budget check and make sure we have enough funding before we come down and do the purchase. Would probably be the logical way to do this. But in this instance, we're just using really beginner logic, and we're just coming through and we're just saying, hey, if this instance isn't an integer or a float, like somebody types in a string, then we're just going to go ahead and reject this. We don't want any, we have no interest if this is no integer or a float here. Then we're going to define our change. So if we have money left over, like if we have budget minus the price of the shoe, then we're going to go ahead and give some money back. And then we're going to buy the shoe as well. So we're going to have our buy option. As long as our budget is greater than the price of the shoe, we can buy that shoe. And if the budget is equal to the price, then we have enough money. If it's not, then we'll actually have some money left over here. Unless it's the instance of not having enough money, and then it'll just exit the application because we haven't told it to do anything else. And then it'll also thank us for using the shoe app. So that's part one. We have defined the class. Now, could we build this out all in one thing? Yes, we could just write a script out for this. We could code this and make it into one easy script. But what this will do is allow us flexibility. This is where object-oriented programming comes into play, because we don't have to continue to repeat ourselves. And what we're following is what is called the dry approach, the don't repeat yourself approach. And so what we're doing is maintaining everything in a class here, and then we'll call that class and make it very easy on us instead of having one crazy long script that is potentially repetitive and a lot more difficult to go through. So here we're going to just open this up, and I'm going to call out a shebang on bin Python 3. I'm going to save this, and I'm going to call this shoe purchase.py. Save that. Now, we're going to import from our class that we made. So from shoes, import shoes. And let's define a few variables. So let's say low is equal to shoes. And for the low price shoes, we're just going to say we can buy some and ones. And we can buy those for $30. For medium price shoes, maybe we can purchase some Air Force Ones. And for those, maybe they're $120. And then for the high price shoes, maybe we're interested in purchasing some off-whites. And those might run us $400. And from here, what we're going to do is we're going to do a try statement. Remember, we've done a try statement before. And we're going to say try. And we're going to say shoe budget is equal to a float of an input. We're going to ask for an input here. So this is all tying together. We'll say, what is your shoe budget? Do a question mark there. Tie this together. And then we're going to do an exception. So if we have a value error, meaning we don't get a number back, similar to what we were doing previously, if we don't get a number back here, we're going to say, please enter a number. Now, we can come in here and say, for shoes in, and then we can just give this high, medium, low, like this. We can do a shoes.buy. And remember, we came out with this buy method over in our class here. So we're doing a shoes.buy, going to go ahead and check all this for us, and we're going to say shoe budget. So we're going to take the input of shoe budget. What's the value here? We'll take that. We'll come in here and we'll see what our budget is. If it is greater than or equal to the price of the shoe, we're defining our name of the shoe and our price of the shoe from our parameters that we defined up here, name and price. So we're saying, hey, the name and the price. So is the price of the shoe, is it at least the amount of our budget? And if it is, we can buy that. And we'll check in the highest order and then go in the lowest order. If you flip these and you put in $400, it would just keep telling you that you can only buy the low price shoe. So you need to make sure it's in the highest to the lowest order in this example. And so it'll check, do we have enough money to buy the $400 pair of shoes? No? Okay, and then do we have enough money to buy the $120 pair of shoes? No? Do we have enough money to buy the $30 pair of shoes? So we'll go through that and iterate in this loop to see what we can or can't buy. So let's go ahead and save this, and we'll save the shoes.py, and I'm going to go ahead and run this. Hopefully I have no typos. We'll do shoe budget, shoe purchase, sorry, and run this, and I do have a typo. And so if I come back in here, I forgot to close off my F string, so let me save that. Now let's try this. What is our shoe budget? So let's give it a few different options. If we said our shoe budget was $30 exactly, well, it's going to say that we can cop some and ones, sorry, and we have exactly enough money for these shoes. Thanks for using the shoe app. What if we had $31? Well, we could still cop some and ones, and then we can buy these shoes and have $1 left over. All right. What if we had $450? Well, we can buy the off-whites, and we can buy those and have $50 left over for our budget. So hopefully this makes sense. I know this is a lot of information, and this, again, is just a 101 course. So we're just kind of dabbling in the object-oriented programming. And if you continue on with Python from here and you start getting into more complex material, then you could build upon what you're learning here. So try to think of something that you might want to script out like this or write out like this, and think of the logic behind it. I highly recommend going and doing coding challenges or programming challenges and try to increase the logic and the ideas behind what you're trying to build. And that just takes practice. All of this takes practice. It's one thing to watch and follow along with somebody. It's a whole nother game to go out and do this yourself. So start thinking of some things that you want to build. Really use your Google skills. Look at Stack Overflow and look at some Googling and some Redditing, and just try to piece together the logic that you have in what you want to build. So highly recommend building upon this. This is a great language to learn and very flexible, and I hope that you continue on with this.